Okay, so for our second problem concerning the integration by algebraic substitution, we are to solve for this equation right here. So we would be getting the integral of square root of y raised to 5 minus 1 divided by y times the differential of y, or dy. So as you might have known already, you cannot use our power formula here or any of our basic formulas right here from the get-go. So we cannot use any of those formulas right away. So since our topic for today is to be method of substitution, what we would be doing is that we would be introducing a certain variable for this certain equation right here to be much more simpler. And once that it would be simple already, we can now use any of these particular formulas right here. What I would be doing right here is that I would be introducing variable x. So variable x. And let's say our variable x is to be equal to this whole function right here. So that is to be the square root of y raised to 5 minus 1. Okay, so we already have this value right here. But what about for y and dy? So using this equation right here, we would now be solving for the values of y and dy. So from that, squaring the whole equation, this is now equal to x squared is equal to y raised to 5 minus 1. And transposing this value, solving for the value for your y. So y raised to 5 is equal to x squared plus 1. And from that, getting the fifth root of both terms, that is to be, so y is now equal to x squared plus 1 raised to 1 over 5. So we already have the value for our y. But what about for dy? So for the value of your dy, so this is to be equal to the derivative of this equation right here. So what is to be the derivative of this one right here? So that is to be equal to, so 1 over 5, which is this one right here, times x squared plus 1 raised to, so 1 over 5 minus 1, that is to be negative 4 over 5. So that is 1/5 minus 1. So times the derivative of this function right here. So the derivative of that is equal to 2x times dx. So if you're getting confused here, it is better for you to review differential calculus first. So this is to be the answer for our dy. So d of y is equal to 2x dx divided by 5 times x squared plus 1 raised to 4 over 5. So this is to be the much more simpler equation for this equation right here. Okay, so now that we have all of this already, what we would be doing is that we would be substituting these values right here to this equation right here for this equation to be much more simpler. So from that, this is to be equal to the integral of, so what would be this one right here? That is to be your variable x. So that is equal to x divided by y, and our y is equal to this one right here, which is x squared plus 1 raised to 1 over 5. So that is for your y. But how about for our dy? So our dy would be as follows. So it would be this one right here. So times 2x dx divided by 5 times x squared plus 1 raised to 4 over 5. So there. So what I would be doing now is to simplify this term right here. So this is now to be equal to the integral of 2x squared dx divided by 5 times, so x squared plus 1 raised to 1 over 5 times x squared plus 1 times 4 over 5. So 1 over 5 plus 4 over 5, that is to be equal to x squared plus 1 raised to 5 over 5, or x squared plus 1 raised to 1. So if you're getting confused there, it is better for you once again to review your basic algebra. So that is to be a basic algebra topic. So from that, what I would now be doing is that I would be segregating our constants right here. So it is then equal to 2 over 5 times the integral of x squared dx over x squared plus 1. Okay, so what would I do next? So as you can see here, the degree of your numerator is equal to the degree of your denominator. So what I would be doing right here, right now, is to divide this numerator right here by this denominator right here. So you can either do a long division or you can just do this instead. So this is to be equal to 2 over 5 times the integral of, since this is to be x squared and this is to be x squared plus 1, so I would be introducing plus 1 here for it to be much more simpler. But if you are getting confused in this method right here, it is better for you to divide this via long division. But once again, I would just be doing this. So x squared, so I would just be introducing 1 here, so plus 1. But take note, guys, that since I have introduced plus 1 here, it is imperative for me to introduce another negative 1 here. So basically, I am just adding 0 here, since plus 1 times negative 1 is equal to 0, for it to have the same value still. So from that, that is to be dx and x squared plus 1. Okay, so now what I would be doing next is that I would be breaking up the numerator. So what I mean here is that this is to be its new equation. So 2 over 5 times the integral of x squared plus 1. So this is to be x squared plus 1 dx divided by x squared plus 1 minus 1. So minus 1 divided by x squared plus 1 times d of x. So what I did here is that I just broke up the numerator. And for you not to get confused, this is basically what I did. So x squared plus 1 divided by x squared plus 1. Then I just separated this. So minus 1 over x squared plus 1 times dx, and I have just distributed this dx right here, which resulted to this equation right here. So if you didn't get that, it is better for you to rewind the video. Okay, so from that, and I have noticed that my equation is at an angle, so I would just be straightening it here. So our simplified equation right now is to be this one, so 2 over 5. By the way, this is to be the integral. Okay. So from that this is to be 2 over 5 times, this is to be x squared plus 1 and x squared plus 1. This would just simply cancel out. So this is to be the integral of dx minus the integral of dx over x squared plus 1. So there, so this is to be for your value right now. Okay, so what we would be doing is that we would be solving for this using the basic formulas. So from that, so 2 over 5. And what would be the integral of dx? So that is to be simply x. So x. So we have used power formula here. How about for this one right here? So if you can remember this basic formula right here, which is, well, this one right here. So du divided by a squared plus u squared is equal to 1 over a arctangent u over a plus c. So we would be using this equation right here, since this equation right here is fairly similar to this equation right here. So once again, this can be written as du over a squared plus u squared. So the integral of that is equal to 1 over a arctangent u over a. So u over a. And in this equation right here, our value for a is equal to 1. So 1 is equal to 1 squared. And for the value of u, this is to be equal to x, which is this one. So substituting known values, this is now equal to, so negative. So what is to be this one right here? So 1 over a. So 1 over a is equal to 1 over 1 times arctangent of u over a. And our u is equal to x divided by 1. So this is to be our answer right now. Okay, so there. and this is to be equal to 2 over 5 times x minus arctangent of x. So we have this one right here as our answer. But take note once again that this is to be the answer of the equation that we have simplified, which is this one right here. But it is not to be the answer here since this is to be in terms of y. And once again, our answer here was to be in terms of the simplified equation. So what we would be doing next is that we would be rediverting it to these values right here using these identities right here that we have introduced earlier. So I would just be moving this. Okay, so in this part right here, I would now be substituting these values right here to this equation right here for us to divert it to its original composition. So this is to be equal to, so 2 over 5 times x, and what would be our x? That is to be y raised to 5 minus 1. So this is to be square root of y raised to 5 minus 1. So this is for the value of x. But what about for our arctangent x? So this is to be equal to, so minus arctangent x, and our x is equal to square root of y raised to 5 minus 1. So it would be this one right here. And don't you forget, guys, our arbitrary constant, so plus c. So plus c. So distributing this constant right here, this is now to be equal to, so 2 times the square root of y raised to 5 minus 1 divided by 5 minus 2 over 5 times arctangent of the square root of y raised to 5 minus 1 plus our arbitrary constant c. So for this particular problem, this is to be our final answer. So there.